Hello, Assalamualaikum. We are from class BA249 4A. We are from group 1, consists of 3 people, Ahmad Aiman, Muhammad Nazim and Muhammad Razin. Today we will show you how to do regression analysis on Excel. So first thing we are going to do now is this is the data, and yes, we chose home market value data, consists of house age, square feet and market value. Okay, so first thing we are going to move our copy, create a copy, move to N, click OK. So now we have duplicate the data from here, and now we are just going to rename it as multi linear regression right. So now there are ribbons up here, so you click on the data ribbon and you search for the data analysis and you click on it, and you'll find a lot of things, and you will search for regression and you click OK. Okay, so input Y range, we are going to choose square feet. For input X range, we are going to choose market value. Okay, because it has labels on, so we click on the labels and residuals and normal probability plots. Okay, here output range is where you want to put the data. So here, for example, I'm gonna choose here, and then you click OK. There it is, your multilinear regression data. Alright, so because this is multilinear regression, so what we are going to do now is we are going to do another one for multilinear regression data. Click on the data analysis. What we are going to do here is we are going to change, earlier input Y range is square feet, so we are going to change to market value. Okay, so input X range here will be square feet, different from earlier. As usual, you click on the labels, residuals and normal probability plots, and for output range, click on besides of the data so you can compare, and you click OK. Alright, so what we are going to have is two different data. Okay, next we are going to do linearity. So to make a new data, we click on here, plus icon here, and then we rename it as linearity. Okay, for linearity, we copy the data from square feet and residuals. I'm going to copy, I'm going to paste here, and residuals. And paste it here. Alright, so just click on here to make everything more. Okay, to compare these two, square feet and residuals, we are going to do a graph to explain these two relationship. First, you click on the insert ribbon, and you will click on the scatter graph, and you click here. Alright, and then you right click to insert the data on here, select data, and then you choose square feet and residuals both at the same time, then you click OK. There it will show you the relationship between these two. Okay, for further explanation from this graph, we can conclude that the residuals scattered about zero pattern, because you can see here at the zero, you can see that it's randomly scattered here, and there is no specific pattern in the graph. So you can just say the explanation here. So we can conclude that the residuals randomly scattered about zero and do not exhibit specific pattern. Okay, next we are going to do normality. As usual, click here and rename it as normality. Okay, for normality, we are going to need the residuals data. Okay, so you just copy from the linearity data, paste here. Okay, for normality, we are going to need histogram. So in order to do that, click on the data. As usual, click on the data analysis, click on histogram. Okay, here for input range, residuals, because it has the label, so you click on the label. For output range, I'm going to click here. Okay, you click OK. So when you already have the bin and frequency data, so we can do histogram graph. In order to do that, click on the insert, click on the histogram data. Okay, still empty for right now. Right click, select data, and you choose from here until more. Okay, I'm going to show you again because there was a mistake before. So I'm going to show you. Click on the insert and you click here in the insert column or bar chart. Click there. In the 2D column, click on the second one, and then you right click and select data, and choose these two and you click OK. There. Okay, from this graph we can conclude that the distribution of the residuals could be said as nearly bell shape, because from the graph you can see that is nearly from a bell shape, so we can conclude that the residuals is normally distributed. So I'm going to distributed. Okay, next we are going to do homoscedasticity. As usual, I already renamed it as homoscedasticity. Okay, for homoscedasticity, we are going to need the residuals graph, the scattered plot. So we are going to choose from the linearity and just copy. Simple as that. Okay, so from this graph the residuals are randomly scattered about 0, you can see here, and do not exhibit a specific pattern. We can conclude that it is homoscedasticity. So I'm just going to save some time and just copy from here. Okay, paste here. Okay, so we can conclude it is homoscedasticity. Okay, next we are going to do autocorrelation. Okay, we are going to use Darwin-Watson formula, and here I have simplified the formula to make it simpler. So I put denominator here and numerator here. Okay, for ET we are going to take from the residuals data. Okay, then you copy and paste. Right, for this one also the same process, but click on the top and you copy. And then you paste. Okay, for this column, t the power of 2 times e. For the usual, click here because it's power of 2. So you click enter and you will get the answer, and you just drag it until down. Alright, Okay, for here as usual, and then you click here, and now because it's minus, click minus, and then the power of 2, so you put these 2, and then the power of 2, then you will get the answer. As usual, you drag. Alright. Okay, so remember, we are not finished yet because it is divide, so we are going to simplify this denominator and numerator. Okay, so sum this and another one, sum okay. Now you get both of the answer, denominator and numerator, and here so numerator is up, divide the denominator, and you will get the answer. Okay, to conclude this, we are going to use rule of thumb. In rule of thumb, there is no autocorrelation between 1.5 until 2.5. Since our Darwin-Watson is 0.9 that we get, so we can conclude that there is autocorrelation that happened. Okay, next we are going to do multicollinearity. Okay, here you must copy data from the first one. Okay, here copy the data, the original data, and you paste it in the multicollinearity. Okay, to do the multicollinearity, click on the data and click on the data analysis, and you choose correlation. In the input range, choose all, and then for output range, I want it to be here. Okay, so when we got the result here, if the correlation value is more than 0.7, it may indicate multicollinearity. So based on this graph, only square feet that is more than 0.7, so we can conclude that square feet is multicollinearity. So we have come to the end of regression analysis. So thank you from us. Enjoy. Assalamualaikum.